Hi, Math 2. Welcome to talking about today's topic, which is imaginary numbers. Now, we talk about imaginary numbers when we're taking the square root of negative numbers, because usually we would have to say that the square root of a negative number has no real solution. But, like we talked about last week, I'm going to define the square root of -1 to equal I. And by doing this, I'm going to be able to simplify my square root of negative numbers in terms of I. Let's look at an example. Part A, the square root of -25. Well, I know that -25 can be rewritten as 25 times -1. So the square root of -25 equals the square root of 25 times the square root of -1. This means that the square root of 25 gives me 5. And the square root of 1 equals I. The square root of -1 equals I. So my answer is 5I. Now for part B, I want to know, hey, what is my square root of -49? Well, that can be rewritten as the square root of 49 times the square root of -1. You know that the square root of 49 is 7. And the square root of -1 equals I. Part C, the square root of -4, I'm going to keep that same pattern going. I'm going to say, oh, the square root of -4 equals the square root of 4 times the square root of -1. Well, the square root of 4 equals 2, and the square root of 1 equals I. Now I can also use this to help me solve for a variable. For instance, I could use this to help me solve for x, like in part D, where we have the equation x squared equals -4. I'm going to work to solve this the same way I have every other problem. We're going to take the square root of the left and the square root of the right. And I'm going to say that x squared equals the positive or negative square root of -4. Sorry, x equals the positive or negative square root of -4. So then as I go to simplify that, we say, oh, x equals positive or negative root 4 root -1. So x equals positive or negative 2I. And there you have it, your introduction to imaginary numbers. Hi, Math 2. We're going to talk about an extension of imaginary numbers in this video, and that is complex numbers. Now, complex numbers are numbers written in the form a plus bi. So they're the sum of a real number, which is the a, and an imaginary number, which is the bi. And I get this because we know that since I equals the square root of -1, I can square both sides and end up with I squared equals -1. Now let's look at how this works when we're simplifying mathematically. If I have 2 plus 3i plus -5 plus 8i, I'm going to combine like terms much like I did when I worked with x's and y's. I have a 2 and a -5, which are both whole real numbers. 2 plus -5 equals -3. Oh, but look, then I have positive 3i plus 8i, that's plus 11i. And that is my simplified answer for part A. Now for part B, I'll notice, look here, we have 2 plus 3i minus negative 5 plus 8i. So I'm first going to simplify by distributing my subtraction. My 2 plus 3i remains the same, but then I have plus 5 minus 8i. As I work to simplify, 2 plus 5 equals 7. Positive 3i minus 8i is subtract 5i. Now part C is a little different, because 2 plus 3i squared really means we have 2 plus 3i times 2 plus 3i. So I'm going to come to the side for a moment, and I'm going to draw an area model to help me multiply this out. Just like if we were doing this with x's, and it was an x plus 3 or x plus 4, we can use my area model to help me multiply this out. So I have 2 plus 3i times 2 plus 3i. And I know that 2 times 2 equals 4. 2 times 3i equals 6i. And again, 2 times 3i equals 6i. Now for the bottom right corner, we have 3i times 3i, which is 9i squared, but I'm going to remember that I squared equals negative 1. So that's really 9 times negative 1, or negative 9. So to get my final simplified answer, 2 plus 3i times 2 plus 3i, that's 4, plus 6i minus 9, or negative 5 plus